And now we come to the very last part of our discussion on optics. We have examples part 3. Sample problem number 6. A diverging lens of focal length f is equal to negative 60 centimeters is used to produce images of a praying mantis. So the object here is the praying mantis. First, the lens is placed 1 meter from the praying mantis. Next, the lens is placed 65 centimeters from the praying mantis. Determine the ratio between the heights of the two images that were formed. So we have a diverging lens. The focal length is given. F is equal to negative 60 centimeters or negative 0.6 meters. We have two cases, the first case and the second case. First case, the lens is 1 meter from the praying mantis, which means the object distance S1 is 1 meter. An image of height h1 prime is produced. Next, the lens location is changed. The lens is placed 65 centimeters from the praying mantis. So for the next case, we have object distance of S2. S2 is equal to 65 centimeters or 0.65 meters. An image of height h2 prime is produced. For both cases, case 1 and case 2, we have the same object, the praying mantis. So there's only one object height. h1 is equal to h2 is equal to h. So let the object height simply be h. We are asked to determine the ratio between the heights of the two images that are formed. First, case 1. Using the equation for image formation, we have 1 over f is equal to 1 over s1 plus 1 over s1 prime. Isolating s1 prime, s1 prime is equal to fs1 divided by s1 minus f. We know f, we know s1, thus we are able to calculate s1 prime. Negative 0.375 meters. We do the same thing for the case 2. We are able to calculate S2 prime. Negative 0.312 meters. For the case 1, knowing S1 prime, knowing S1, we are able to determine the lateral magnification M1. M1 is equal to negative S1 prime divided by S1 is equal to H1 prime divided by H1. We are able to determine an equation for H1 prime. Isolating H1 prime, we get negative H1 S1 prime divided by S1. H1 is just equal to H. Thus, H1 prime is equal to 0.375 H. Doing the same thing for lateral magnification M2. M2 is equal to negative S2 prime divided by S2 is equal to H2 prime divided by H2. Isolating H2 prime, we get 0.48 H. Getting now the ratio between H1 prime and H2 prime. H1 prime divided by H2 prime, we get 0.78125. We can cancel out H. Thus, final answer, the ratio between the two images that were formed H1 prime divided by H2 prime is equal to 0.781. And finally, we have sample problem number 7. An apple is placed 1 meter in front of a concave mirror, focal length 30 centimeters. A converging lens is placed between the apple and the mirror, focal length 60 centimeters. So you have a mirror and an apple. Lens is placed between the mirror and the apple. The lens forms an image of the apple, and from this image, the mirror forms an image. If the distance between the lens and the mirror is 20 centimeters, determine the distance between the apple and the image formed by the mirror. So we are provided the focal length of the mirror, 30 centimeters or 0.3 meters. Concave mirror, so positive focal length. Converging lens, FL, 60 centimeters or 0.6 meters. Converging lens, so positive focal length. We are being asked to get the distance between the apple and the image formed by the mirror. So you have an apple, lens, and mirror. The mirror and the apple are 1 meter apart, and the lens and the mirror are 0.2 meters apart. First, as mentioned by the problem, the lens will produce an image of the apple, and it is this image that the mirror will see. So first, the lens produces an image of the apple. The distance between the apple and the lens, SL, object distance for the lens, SL is just 0.8 meters. Using the equation for image formation for the lens, you have 1 over FL is equal to 1 over SL plus 1 over SL prime. Isolating SL prime, FL times SL divided by SL minus FL. We know all these values. We know FL, we know SL, thus we are able to determine SL prime 2.4 meters. Image distance is positive, meaning the image is behind the lens. It is this image that the mirror will see. This image will be the object of the mirror. And that image is behind the mirror. That object image from the lens will be behind the mirror. And so we use the image produced by the lens as the object for the mirror. And since the image produced by the lens is behind the mirror, this object for the mirror, this object is behind the mirror, so object distance for the mirror will be negative. We have a case of negative object distance. Object distance, as previously mentioned, is typically positive, but in some cases, object distance may be negative. And in this case, we have just that, negative object distance. SM is equal to negative 2.2 meters. Using the equation for image formation, you have 1 over Fm is equal to 1 over Sm plus 1 over Sm prime. Isolating Sm prime, Fm times Sm divided by Sm minus Fm, kumpleto, we are able to calculate Sm prime, 0.264 meters. Positive, this means the image formed by the mirror is in front of the mirror. 0.264 meters in front of the mirror. Thus, we are able to determine the distance between the apple and the image formed by the mirror. The apple and the mirror are 1 meter apart. The image formed by the mirror is 0.264 meters in front of the mirror. Thus, distance D is just equal to 1 minus Sm prime. D, therefore, is equal to 0.736 meters. And that's it for our discussion on examples part 3. That's it for our discussion on optics. So thank you for watching.